Good evening, everyone. This is Sang Yun and Di Huang. I'm going to talk about evaluation metrics. I did learn this material from university back in my bachelor's program. So I'm going to present to you about the stuff that I learned from uh, back in my university because I think this is also very important, and especially because the material that I have here is very well summarized, so I'm going to share it with you guys and going to talk about this in a few minutes. Um, so imagine the situation that we have algorithm to classify whether the documents are relevant and not relevant. So the goal of evaluation metrics here is to measure the quality of a particular ranking of non-relevant or non-relevant documents. So we have concept called self-retrieval. So basically it's talking about precision and recall. So imagine that we have a set of REL, which is like a relevant documents, and we have another set which is called RET, which is retrieved documents. So we assume that this relationship holds, and we are going to talk about precision and recall. And precision is the proportion of retrieved documents that are relevant. So in the formula, you can see that this is basically RET and REL divided by total number of REL. So basically the precision is when given that documents are retrieved, how many of those retrieved documents are actually relevant in this case. And recall, we are talking about the proportion of relevant documents that are retrieved. In this case, we're talking about given that the documents are relevant, how many of those relevant documents are actually retrieved. So we have two different measurements, and the recall measures the system's ability to find all the relevant documents, whereas precision measures the system's ability to reject any non-relevant documents in the retrieved set. So the rest of them is self-explainable, so I hope this is very clear to you. The system can make two types of error. A first positive error. The system retrieves a document that is non-relevant, should not have been retrieved. And the other error is the first negative error. The system fails to retrieve a document that is relevant, should have been retrieved. So how do these types of errors affect precision and recall? So precision is basically affected by number of first positive errors, and recall is affected by the number of first negative errors. So basically, I'm also referring to one of the readings that we had from recommender system in R. So it basically talks about how precision is affected by first positive and recall is affected by first negative. So in case if you guys also wonder, I would suggest you to go back to that book to understand this in more detail. So ideally, we want a system that has high precision and high recall. So we have a trade-off. We want a metric that measures the balance between the precision and recall. So in order to do that, the one possibility that we can think of is to use the simple arithmetic mean. So basically, we do the sum of P and R, or precision and recall, and divide it by 2. But it is a problem. The problem here is that it doesn't really show you how balanced we have. Balanced precision or recall ratio we have. So bad example here is that a system sometimes obtains 1.0 precision, the perfect precision, and near zero recall, but we will still get the mean value, arithmetic mean value of 0.5. Another bad example is that the system has perfect recall but 0% precision, again the same mean value of 0.5. So the better one, which is the optimal one that we want to achieve in this case, given the same mean value of about 0.5, is that when system obtains 0.5 precision and also 0.5 recall. So that means we have a balance in precision and recall. So in order to avoid some of those issues, unbalanced issue, the other thing we can think of is F measurement. So F measure is also known as F1. It's a system that retrieves a single relevant document would get 1.0 precision and near 0.0 recall. A system that retrieves the entire collection would get 1.0 recall and near 0.0 precision. So yeah, those are the problems that we actually discussed before, and the solution is to use the harmonic mean rather than the arithmetic mean. So in this case, we can actually see the balance between the precision and recall using the F measurement. So as you can see, the harmonic mean punishes small values, and as you can see from this graph, using the arithmetic mean, you don't really see that small values are being punished. Whereas in this diagram to the right, you can see that it's almost looking like geometric function. So you have F1 and recall. You see the difference here. And we have a ranked retrieval, meaning that we can actually rank the list of documents rather than an unordered set. So in most cases, this is because the system outputs a ranked list of documents rather than an unordered set. So the ranking is also very, very important. So assumption here is that the user examines the output ranking from top to bottom until he or she is satisfied or gives up. The precision and recall can also be used to evaluate the ranking. So precision or recall at the rank K is also another thing to look at. As we already know, the precision is a proportion of retrieved documents that are relevant, and recall proportion of relevant documents that are retrieved. And from there, we want to take the rank. Let's say P at Q is like a precision precision at K. It's basically the proportion of top K documents that are relevant. So basically, we want to just get the proportion of, let's say, top 10 documents that are relevant. So RIK, similar. So the proportion of relevant documents that are in the top 10. So assumption is that the user will only examine the top 10 results in this case, if let's say the K is 10. So here are the examples. So when the K is 1, you are going to get all this the measurement by hand. So I'm not going to talk about all the details here, but I'm just going to show you how it's being done. So if it's 2, you continue this until you reach the K equals 20. So thank you for your time, and this is my presentation on understanding different metrics in evaluating recommender system.